Benny John, Assistant Professor, Mechanical Engineering. Today, we are going to see about Theory of Machines, Unit 1, Kinetics of Mechanism. In this chapter, we are going to see about velocity and acceleration diagram. First, there is a relative velocity of two bodies moving in straight line. As we have discussed about the parallel lines, while consider the line AB moving along with parallel lines. Similarly, the relative velocity is respected with the equal to difference of Vb equal to Va vector minus Vb vector. In this figure, we can see about while the A can move and B can move rightwardsly. That's the source the relative motion of the velocity diagram. Next, there is a concept the V is moving inclined direction that is shown in figure, that is the B section. While the B is inclined with A, that is known as parallelogram and triangular motion that can make the fixed point with draw the vector diagram. In this figure, we can see about that the O is the fixed point. Next, A is moved towards that's a parallelogram and inclined AB line. That shows the VB is moved towards opposite direction. Similarly, that shows that A with relative velocity of A with respect to B. Next, the motion of links. The consider two points A and B are rigid links. Next, the one extreme B is moved towards relative A that will move clockwise direction. Since the distance of A to B is remains same for there is no relative motion between A and B. Obviously, the relative motion with respect to A it is perpendicular to B. The velocity of the point is no to another points of same links. It is perpendicular for the space diagram. Next, velocity of the point. The link by relative velocity. Consider the two lines points A and B. In the links that is shown in the figure, that the absolute velocity of A is known as VA, magnitude and direction. Next, absolute of the velocity, this is VB, is known as direction only. The velocity B determines the drawing of velocity diagram that is shown for components. Next, rubbing velocity. The links in a mechanism are mostly connected by the means of pin joints. The rubbing velocity is defined as the algebraic sum between angular velocities of two links which are connected by pin joint multiplied by radius of pin. Let us consider the two links, that is OA and OB, are connected by pin joint that center O. The omega, let us omega is omega 2 or angular velocity, r is radius. According to the part of rubbing velocity is omega 1 minus omega 2 r. If the link moves same direction, omega plus omega 2 into r if the links moves opposite direction. While it is rubbing velocity at a pin point equal to omega r, where omega equal to angular velocity, r equal to radius of pin. That shows the pin when the pin connects the one sliding member and then another member, that's the sliding member is zero. That's the problem. In this mechanism, as shown in the figure, the crank OA rotates at 20 rpm and anti-clockwise and gives us motion to the sliding blocks B and D. The dimensions of the various links are OA 300 mm, AB 1200 mm, BC 450 mm, and CD 450 mm. For the given configuration, the determine velocity of sliding at B and D to angular velocity CD, linear acceleration of D, and angular acceleration of CD. There is a solution. The given data is n, that is a speed to 20 rpm, and omega AO, that's the formula is 2 pi into 20 by 60, that's 2.1 radius per second. Next, OA, that's the value is 300 mm, in it is converted into meter, that is 0.3, and AB 1200 mm, and BC and CD equal to 450 mm. We know that the formula of linear velocity with respect to O, that VA equal to omega into OA, that's the value is 2.1 into 0.3 equal to 0.63 meters. Next we can draw the velocity sphere rough diagram. That's the OA from perpendicular to O. We can calculate that VA equal to 0.63. From a point, A point is where fixed with, draw the A vector diagram AB with perpendicular to A, and divide the vector AB at C the same ratio. C will divide AB the space diagram. Invest the BC bar CA equal to the BC by CA. Now point C, draw the vector CD perpendicular to CD that represent velocity of D. By the measurement, we can find the velocity at B is V equal to 0.4 meter per second, and while velocity of sliding at D, Vd equal to 0.24 meter per second. Next, you can find that linear acceleration of the diagram. First, the omega A equal to V square AO by OA. That's the formula is omega square AO into OA. That's the point is 2.1 square into zero point 0.3. That's the answer is 1.323 meter per second. While the radial components of acceleration with respect to B and D, it is forgets the formula value is 0.234 meter per square and 0.34 meters per second square. Similarly, the diagrams are varied with the measurement, the linear acceleration of diagram. The answer is 0.16 meter per second. Then angular velocity is find. That's the answer shown. That similarly the diagram will moves that the angular acceleration alpha CD equal to ATDC by CD. That's the value is 1.28 by 0.48. This answer is 2.84 radian per second square. That's all. Thank you.